Hello everyone, Siddharth this side, and in this video we will be solving another question from the list that I have shared. That is 2 sum 4. Input is binary search tree. So let's read out the question first. So we have given the root of binary search tree and an integer k, and we have to return true if there is exist two pair of element in this binary search tree whose sum is equals to k. So from this is a very easy question. If you we will go for the brute force method, then it will be very easy for us to solve this question. So let's see first the brute force, then we will be going for the efficient approach. So this is in tree. Let me draw it first. So 5, then 3 to 4. So 3, then 2, and then 4, then 6 and 7. This is 6 and then 7. Now the brute force method for this tree will going to be, we can do what we can do, we can apply any in order, pre-order and post-order traversal, and then we will store all the elements of this tree into an array. Suppose we have done like this. I'm not maintaining the order, I'm just telling you for the how we can approach this. Now after storing all the element in this array, first we will sort this array, and then we will apply the two sum question approach, which is the first video that I have uploaded on this playlist. So this is one solution, guys. You can find out the duplicate from this array, and the efficient approach is, in the efficient approach we will be for applying BFS for this current tree, and after applying BFS we will be simply checking for the current element. Suppose the current element is 3 and the target is 6, so we will be checking 6 minus 3 is 3. If this is present into the hash set that we will be maintaining throughout this question, if this is available, then simply we will be returning true, otherwise we will be returning false uh, in the base case. Okay, and in the same manner that we add element in the queue, before that we will be adding element in the hash set as well, before adding the element into the queue. And in this manner we can solve this question. And if you haven't done the questions on BFS, then I would say you can watch the video that I have already uploaded on my YouTube channel. You can simply search BFS and you can study from there, and then you can try to solve this question, and you can then easily able to solve this question. So now let's code this out as well. So first we have to make an queue. So QUE, and we will be making of tree node. Okay, after doing this, or we can simply made it of node, no need for tree node. Okay, and let's name it as q is equals to new linked list. Okay, after making this we can make an hash set where we will be storing each element that we will be traversing level by level using breadth first search. Okay, then this will also be storing integer and hash set, then new hash set. Okay, after doing this, just we have to call our BFS method, return our BFS method, and then we just have to make that a function. So we will be returning BFS, and we will be passing, first we will be passing our root node, so tree node root, then we will be passing integer k, and then we will be passing q, which is q, and then we will be passing our hash set. Now let's make the function as well, which is public. This is also boolean return type, and we will be naming is that as BFS. Then we will be passing everything here as well, so tree node root, and then int k. Let me copy this and paste. Then we will be passing our hash set. Let me copy this as well and paste here, and then we have to pass q. So let me do it same for this also. Now we simply have to check if root is equals to null. If this is the case, then we simply have to return the false, and then we simply have to perform breadth first search. For that, that is in standard method. So first we have to push our current root into the queue. So for that, queue dot offer, and we will be pushing the first element into the queue, which is root. And after doing this, we just have to uh, start breadth first search. Now while, let me do the not operator. So queue dot uh, is empty, so this will return boolean. Now after doing this, we have to pull out the current node. So node current, so this is in current node. For that, this should be tree node. So tree node current, and it this will equals to queue dot poll. Now after polling out the current node, we have to check the difference as well, if that is present into an hash set or not. For that, int difference, we can name it as difference. Now what we have to do, we have to subtract it from the k value. So k minus current dot val. So current dot val, here already given, we have to use dot val for finding the value. Now after doing this, after finding the difference of the current node from the value of k, what we have to do, uh, so if our hash, which is hs dot contains, if our hash set contains this difference, then simply we have to return true. Otherwise we have to add that into our hash set. So hs dot add the current node, current dot val, because we have to store the integer value, not node, into our hash set. Now after doing this, we simply have to do the same thing that we have done in breadth first search. So if root dot left does not equals to null, then we will be adding that into the queue. So queue dot offer root dot left. Okay, same for if a root dot right does not equals to null, then we just have to add that as well into our queue. So root dot right. Now after doing this, here we will be returning false, here we will be returning true, and we are running this method, we are polling, then we are finding the difference, we are checking whether our hash set contains the difference. Okay, now let's try to run this. Okay guys, so the issue is here, first we have to apply this, and then we have interchange the position of this hs and q. Here we have passed this here q first, and then we have passed the hash set, so we have to interchange that as well. So here we can pass hs, and here we can pass q. And then another issue is we haven't, this should be current, not root. Okay, after this, okay, so this will going to be current dot left and current dot right. Now let's try to run this. Now let's try to submit this as well. So all the test case have been passed. So see you in the next video. Bye.